The second part of external lightning protection system, that is down conductor system. Down conductor system is a part of external LPS which provides the shortest path for the lightning current to flow from the air termination system to the earth termination system. In order to reduce the probability of damage due to lightning current flowing in the LPS, the down conductor shall be arranged in such a way that form the point of strike to earth. Several parallel current paths exist as per LPL, as per IEC 62305 Part 3. The length of the lightning current paths are kept to minimum. Equipotential bonding to conducting parts of the structure. An equal spacing of down conductor is specified as per the class of LPS as defined in the below table. So if the class of LPS is 1, the typical distance between the down conductor shall be 10 meters. If it's LPS 2, then also the spacing between two adjacent down conductor has to be 10 meters. If it's LPS class 3, then the distance becomes 15 meter, and finally for LPS 4, the distance between two down conductor goes to 20 meter. However, if the down conductor cannot be routed in equal spacing due to some constructional constraint, a 20% tolerance is accepted as mentioned in IEC 62305-3. Down conductor system. The down conductor system shall be installed straight and in vertical ways such that they are routed in the shortest possible path to the earth. All the down conductors shall be directly terminated to a dedicated lightning pit. Down conductors shall not be connected to other earthing conductors above the ground level. Each down conductor shall be provided with a test link at 1.5 meter above the finished floor level or above ground for the testing continuity purpose. Also, a flash counter at any safe area of the plant shall be installed to determine the annual number of lightning flashes that is occurring in the plant as a measure of caution. Let us understand the external lightning protection system design through a typical diagram, and let us understand its different parts. So a typical diagram for external lightning protection system is shown below with the part number for easy understanding. So this is a building, as you can see, different numbers are shown here for understanding. So first, number 1, which is shown here, which we see here, this one is the air terminal with a supporting mast. This number 2 is air terminal with a base support. Number 3, which we see here, is the aluminium, copper or GI conductor which is running on the roof. Number 4 is basically the conductor holding clamp above which the down conductor is being routed. Number 5, we see a cross splicer. In the number 6, here we see a straight splicer. In the number 7, we are seeing an expansion piece here. Number 8, we are seeing basically a saddle support for the down conductor to go down. In the number 9, as we have mentioned, at almost 1500 mm from the finished floor level or ground, we have placed a test link to measure the continuity of the earthing link, lightning protection. And number 12, inside the switchboard which you see in the incomer, there is a surge protection device. So this is how an entire external lightning protection system is designed. So conductor material and minimum cross sections for external lightning protection system. So the material configurations and minimum cross sectional areas of air termination conductors, rods and down conductors shall be selected as per table 6 of IEC 62305 part 3. So as we can see in the left column, the material is provided with configuration and the minimum cross sectional area in millimeter square. So if the material is copper or tin plated copper, configurations can be solid tape, solid round or stranded. But in each cases, the minimum cross sectional area is 50 square mm or 8 mm dia. If the material is aluminium, solid tape, then the minimum cross sectional area has to be 70 mm square. If it's a solid round conductor, then 50 square mm would suffice the purpose. If it is stranded, then 50 square mm would be the minimum cross sectional area. If it's an aluminium alloy and it's solid tape in configuration, then 50 square mm would be the minimum cross sectional area. For solid round and stranded cross section also, 50 square mm would be the minimum cross sectional area. If it's a hot dip galvanized steel, then for solid tape, solid round and stranded all configurations, the minimum cross sectional area would be 50 square mm, which is ideally 8 mm dia. However, as a word of caution, during installation, bimetallic corrosion provision needs to be considered. And also for installations near sea due to high corrosion, SS material shall be preferred for better life of the earthing and lightning down conductors.